Good morning, good morning. So the idea is to continue working on the blobs today, and I think we made some nice progress yesterday with the introduction of a math node in our graph toolkit for procedurally generating creatures, which means that we can now create some sort of relationship between generated float values, or eventually it's going to be integers and stuff like that as well, but for now it's just floats, which means that when we create the soft body here, we can base the joint radius, which are these small colliders here. We can base those on the full radius for the full blob. So we'll randomly generate a float value between 0.2 and 0.6 inclusive, and then we multiply that one with 0.1, and that is the joint radius we have. And this is where we're going to continue, because I want to... I don't know if we're gonna... or we're gonna continue working with this node. We're definitely gonna experiment a little bit more with the actual radius. So we can see here that it's a little bit too small right now, and also I'm also noticing that, like, I'm wondering why we have them outside of the blob here. They should be located inside. That might be some... Definitely wonder what the reason for that is. And then we're also gonna add some, because I think when we do like blob, altering the blob like this, we don't recalculate the normals. We're gonna do that as well, so we get a little bit of a nicer effect for it. So yeah, we have our work cut out for us today. First of all, I want to get to the bottom of why we are seeing bones located outside. The idea is that they should pretty much be positioned like this, or actually like this. This one is perfectly located. I wonder why this one works, but this one does not. It could be because of the... so we use a mesh with less topology when we generate the soft body bones. Can we really get this much of a difference? Let's see. Sphere collider radius. Okay, so we have a radius here, and we have the center offsetted like this. And that looks to be all right. Ish. Let's try generating it once more and see what kind of result we get then. It might very well be the initial drop. We do have a box collider on this one. I don't see it. Okay, we have it out here. Okay, so these have a lot way better position. I'm wondering if it might actually not be a problem itself. But definitely let's try and make the colliders a little bit bigger. First of all. Then we're going to see if we can do anything about this. So let's go with... Yo, what's up, Derek? Let's go with... We could probably calculate this mathematically, but let's go with 0.4 and see what we get. Derek, that looks so good. Thank you, appreciate it. Yeah, we're definitely getting closer and closer to... like a result I'm happy with. .4 is a little bit... Okay, 0.4 gives us colliders that are pretty much colliding by default, and we want to be like right under this. We don't want them to be colliding this much, I don't think, because then we're gonna get results like this. Definitely closer, I would say, because then we basically have something like this. That's not much of a soft body. Let's try 0.3 next. Some of these values are definitely going to have to... Okay, I don't want to rotate it. Some of these values are going to be... We're going to arrive at by testing, and some of them we will probably calculate. This is a very nice blob, I would say. And now with all the bones it looks like this. I'm still a little bit annoyed that we have them outside like this. But this is way better, I would say. This actually looks pretty damn good. Let's try it as well. And we're also randomizing the spring values here. So this one has a pretty loose, not a very strong spring, and we have a little bit more damper, which means that we can move them a lot, and they have a pretty slow bounce. But I think this is pretty good. This is like good for a blob that is pretty firm, I would say. Looks pretty good. We have a little bit too big of a collider here. So the collider for the blob itself is pretty much encapsulating the full blob currently. I think we're gonna switch it to the typical character collider you see, which is a capsule collider. And we're gonna make the capsule collider have a very small radius. So eventually we will have a capsule collider that is... you can see the box collider here, the green square. Eventually we will have a capsule collider that basically looks like 0.2, 3 maybe. that is this thick, which means that other characters and stuff in the world can move into the blob. And I think we will also make it so that this blob can't rotate around X and Z. So like this, which means that we can get interactions like this, which I'm gonna love. This actually looks pretty fucking good. If we can get some normal recalculations of this, this would be beautiful. And then we're gonna have to avoid, or try and avoid, at some points we can get something, like we can get colliders that are interlacing with each other, so we get a permanently deformed blob. That is definitely something we want to avoid. But holy shit, does this look good. God damn. This was kind of like a result I would have hoped for when starting this. Then you always have like improvements that can be made, but it's pretty damn good. Now, yeah, now we have some interlacing colliders here, I think. Some collider got stuck where it doesn't belong. I wonder which one it is. So we're gonna have to come up with a solution where we can force it out again. So we don't get a permanently deformed blob, you know. Worst case scenario, we're gonna have to do a custom solution for it. So we have a script that checks the joints every now and then. But best case scenario, we can solve this. Fuck, this looks good. Best case scenario, we can solve it by joint setup themselves, right? I can play around with this one forever, I think. And eventually I would also love, like, something I've been wanting to do for quite a while is like feeding, oops. That's not the one I want to move. Like feeding blobs food. Okay, this blob has some quite a lot of blur and refraction, but like if we could actually, if blobs would eat like this and then add some nice dissolve shader on the object being consumed, it would look fucking beautiful. But we're gonna get to that later on. Probably have to disable those. But okay, let's see what we can do for as for the to do today. I don't know how I want to... I don't know if I want eyes for my blobs yet or not. We'll see. Base the joint. This one is done. Okay, so we're gonna make the collider. So we're gonna extend our... We're gonna extend this one. I think we already have the functionality for this one. But we're gonna fix these two first. So let's start with the rigid body. We add the rigid body here, and then we have constraints, and fuck, with how the current constraints are set up, we don't have the option to do freeze rotation on X and Y, or do we? Freeze rotation X, freeze rotation Z. Okay, we're gonna have to make this one be...
We gonna kick the beat or what? We're gonna kick the beat. We're gonna kick the ill beat.
Would like to select both of these. Let's just see if this setting does what I think it does. We should freeze them by X currently, right? Blob rigid body, yeah, we have it frozen on X currently. So let's see if we can make it freeze on the other two. And then I want to add one more thing to do. I'm gonna add it here. Add normal recalculations to the blob skin mesh rubber. One sec as well. I'm gonna grab a cup of coffee real quick. Okay, back, sorry about that. So, now to the question. So our custom graph here, it's add rigid body editor node. One sec. Okay, back. Sorry about that. Let's see. Okay, so the option we have is here. And we actually just use rigid body constraints, which is a struct defined or an enum defined by Unity engine. So I don't know if we have an option 2. Like allow for multiple options to be selected. I'm pretty sure there should be a way to click both freeze rotation X and freeze rotation Z. Let's take a look at how rigid body constraints is defined. Oops. Oh, but we're just going to start like this. I think there's a little bit of a special case since we're working with Unity Graph Toolkit. I don't know if we can play around with this lags. With flags enum would be amazing. Unfortunately, I don't think it does. Let's see, context, I option definition context. It might be I definition context. I option definition context. Let's go 0.4. I option builder. Which inherits from... Okay, it's just an interface. I think we're gonna have to do a little bit of a workaround here for now. So let's do it like this. Constraints. Temporary work around to allow for multiple constraints. And we're just gonna call this one 1. And then we're gonna do I definitely want it here as well. And then we're gonna do a second one that is 2, thank you. And we'll change this one to 1, and then we add the second one. And then we want to get these values here. Let's fix this one, and constraints 2. Let's change this one to 1. And we added 2. So now we have 2 here, and then we do constraints 1, constraints 2. That should probably be enough for our little workaround. I think, what are we running? We're running Unity version 6.3. And I know I've heard that we have a few changes to the graph toolkit in 6.4, I guess. Hopefully this is one of these things. Yes, so instead we're gonna do something like use gravity, we're gonna do freeze rotation X, freeze rotation Z. Let's see if this works. Save this one and let's play it. And here we have our blob. Let's take a look. Rigid body freeze rotation X and Z. That's perfect. That is perfect. Okay, so that is this one. It's a temporary solution, but it works. To do yeah. So let's see if we can make the collider of the blobs be thin, and yeah, we're gonna go with a capsule collider. I think that's definitely gonna be the better option for our blobs, for all characters in the game actually. The thing is that we have set collider editor node, we have input type bounds, box, sphere, capsule. We have the option of capsule here, but I'm not entirely sure we have it implemented. So set collider editor node, we have bound, sphere and mesh. For all of the other ones we just do a box collider. So let's implement this one first. I'm just gonna add it to my here. Implement okay. Okay. So first of all, we're gonna run to the set collider runtime node. We're gonna add a subclass that is set capsule collider runtime, set mesh collider, set sphere collider, and set box collider. Can probably merge these or introduce another base class here eventually set. So and let's see here, how do we want to do it? Yeah, I want a radius input eventually. Input count 2, we're gonna have a game object, and then we're gonna have a radius. We're actually gonna have 2. We're gonna have input count 3. And we're gonna make this one into a float. I think we're gonna have radius and height. Can output game object. Height, radius, beautiful. Capsule collider. Height, radius, great. I do wonder if we want an offset. I guess we're gonna notice that eventually. If we need one or not. Okay, and then we run to set collider editor node, and if do we have it, capsule is before mesh. No float. Okay, we call this one sphere radius. Let's copy both of these, put them here, and capsule height, capsule radius. Can we get some change here? Capsule height input, capsule. Yes. I think that's it. Let's see if we can generate this capsule collider. And we're going to use the new math node 2 times here, I think. We're going to take the radius of the blob and we're going to multiply it with, I don't know, 0.8, 0.6 maybe for the height. And extremely slow at reloading here these last couple of days. So where do we have it? Set collider editor node. We're going to change this one to a capsule. Capsule height. Math. Editor node. It's going to be multiplication, and I want 2 of these. And then we're also going to add a random editor node. It's not going to be very random, but 0.6, 0.6. We're going to start with that for the height. And we're gonna have, I wanted to say 0.2 for the radius. We'll test it and see how it goes. And then we want to take, yeah, this one. Here. And here. Okay, it's growing. So this is our graph for the, fuck, do we use this one? No, we don't use this one anymore. for our blobs. Let's see what we get. So this time around we're gonna get a capsule collider for it. We're gonna freeze on X and Z, and the capsule collider is gonna have a height of 0.6 times the blob radius and a radius of 0.2 times the blob radius. No errors. Unfortunately, the blob got stuck here, but that's okay. We'll just move that one to the side. That's a god-awful shape for the blob, I think. Looks pretty shit. But that's how it's gonna be with some procedurally generated creatures. Okay, this is a pretty unfortunate. Do we have a separate height? Makes me wonder, because this looks like shit, but let's see here. And behaves like shit as well. Joint. But okay, let's see the capsule collider. Where do we have one? We do have a capsule collider here with a radius 0.1 and height 0.3. Let's take a closer look at that one by disabling these. And let's jump to this one. Where is our... Okay. Yeah, I might have gone a little bit overboard with the height, most of all, I think. Problem is... where do we have the center? Yeah, we're gonna have to offset the center as well. Oh, actually, this is the radius, this is the height. Radius would probably want 0.3. Okay, let's do... Let's try with... 0.9 for height. I guess we're gonna have to add some offset here as well. Definitely. And then we do 0.4. 0.5 actually. Well, you know, yeah, 0.5. And here we have our blob. That one looks much better. We have a little bit of a weird deformation here, which I'm not thrilled about. We can see the topology look a little bit messy here. I wonder what values we decided on for the soft body here. And I'm talking about skin method parameter -4. Yeah, we haven't added that one yet. Let's see here. Soft body editor node. It might be hard coded actually in the soft body runtime node. Okay, we skin it to 4 bones. That's probably why we get the -4 together with 4 bones gives these type of artifacts. We want to get rid of that eventually. Because it's going to look a little bit jagged, I think. But that's not what I want to worry about right now. Okay. Really? Basing the height on the radius doesn't really seem to give us the result I want. But this is probably okay for a radius. Doesn't look very good. We're still getting a little bit too big bones here, I think, for most of them. So 2. And then I wonder, when we generate this one, we have orgo radius. So if we do capsule height, if we do 1 here. Oh, you know what? We probably want yeah. So the capsule height, we probably want to go like this. Yeah, we want 2 times the radius. Because for the height, we want it to be as big as the diameter. So let's save this and try it again. And we have our blob over here. It looks a little bit more blobby, I would say. That's probably something we want to avoid. That is fixed with a, I would guess, angular damping. Do we have... How do we get artifacts like this now? 10 kilograms per joint is probably a bit too much, especially when we're working with springs. These are pretty strong springs. But okay, yeah, like worst case scenario, we get a very high mass for the joints and a not so strong spring and a very low damper, which means that the blob is gonna be extremely much like Jello. It's not too bad actually, but if we have a setup like this type of problem, so the interlacing problem is gonna be, it's gonna happen way more often. As for the blob dynamics, it's pretty good though. I want to see what happens if we do soft body. I wonder, skin parameter -2. I think, or do we want to go higher there? I don't remember. Should probably add a tooltip. Not for myself. Yeah, okay, so extremely heavy soft body joints together with a not so heavy blob, it's gonna lead to this breakdancing artifact we see here. Yeah, okay, we want to go higher. Let's go pretty extreme and do -8 for this one. We got a pretty big blob this time around. And we'll take this one. Yeah, this is much better. So we can see now that vertices far away from the bone are not affected that much. We're still gonna get like a cutoff here. We can see this vertex not moving at all, while its neighbor is moving a little bit. But this is way better than what we had initially. The radius for these seems to be extremely small, I would say. We want to fill this one out a bit more. We still have the rotating problem. Yeah, we do. This is probably like what a happy animation would look like, something like this. And when it comes to rigid body angular damping, this is probably something we want to randomize as well. What I'm a little bit worried about is the fact that, so when we had the smaller blobs, with smaller blobs, 0.3 multiplication for the joint radius is a bit too small. But for, what's this? Okay, but for the bigger blobs, 0.2 is way too small. So I don't think we have a linear scale here. It's volume, right? So it should be... Yeah, when it comes to the math node, we're probably gonna have to extend it a bit. Because I think we need to add to the power of... what is the volume for a sphere? I don't care about... So we don't really have exactly spheres here. We have misshaped spheres. But volume for a sphere is that 2 pi radius. Or no, that's... I should really know this. Uh, 4 pi r to the power of 3 divided by 3. Because basically we want... we want the volume of each separate bone sphere to be roughly equal to the full volume. We can get into that eventually. Just a linear multiplication will work for now, I guess. Still a little bit. Is it because they are extremely heavy? So I'm talking about this offset we see here. I'm not a big fan of it. I would like these to be located way more towards the... I would like them to be located sphere collider center, pretty much here, I guess. But now when I see it, it's not. It's actually the bone itself that is located. It's also rotated quite a bit wrongly, I think. This one is pretty good though. Okay, so let's add 2 to-dos. I want to have properly calculate the joint radius using sphere volume equation, which is 3 divided by, come on, 4 pi r. And also add option for angular drag to blob rigid body. And what more? Add graph options for number of skinning bones. And possibly add graph option for varying skin variable. If we can get these in place today, I would probably, and we get them in place and we have them working. If we can manage that, I would pretty much be happy and call it quits on the blob generation. But it's a pretty big ask. This one is going to be a mess. This one is done. So add normal recalculations to the blob SMR. We have, let's see here, test. So we need a component that does something like this. Recalculate bounds. I think we need to do that. Procedurally. Must recalculate normals for a skinned mesh runner that uses physics. Let's see, something like that. I wonder if this is the best we got. Creating a new mesh like this, baking a mesh, recalculating stuff, taking the normals and tangents, or a custom solution. I don't know. Unity skinning already transform normals? I don't think so. It doesn't look like it, definitely. Okay. No per frame. Oh, that's true. That is true. Shared mesh is okay because each of them has a separate mesh actually. But this is yeah, maybe. We should do shader based eventually. We'll see. Let me just see why. I don't think we are getting proper normal recalculations on this skin mesh render, because if we do this, we can see that the rim lighting is becoming way thicker, right? Yeah, you can see here this rim shading here, we're getting shadows here, but that's based on vertex position and not normals. What we should be getting is, we should probably be getting some sort of diffuse shading here, making it darker. The rim lighting should be way better. We can try this by adding a custom script which recalculates it every frame, and then we do this test again, and I'm pretty sure we're gonna get a way better result. Eventually we would probably want to move it to GPU because it's gonna be costly as hell. But okay, let's start by doing scripts, creature visuals generation. We have a soft body here, soft body generator. We're gonna have a soft body handler as well, which we're gonna add. And the soft body handler is gonna fetch the skin mesh renderer. And create some stuff. So mono behavior, and then we're going to call it soft body handler. Yeah, it might get some other workload eventually. And first of all, we're going to do this, and we're going to do this. I think I'm also questioning. Okay, putting it in late update if we do purely physics based, we should only see changes in the skin mesh render on fixed update. But if we do like interpolation and stuff like that, then I guess we might see it between. So late update might be a better option. But let's jump to test. We take this fixed update and we put it here. And we're gonna have a private skinned mesh render SMR. Call it skinned mesh render. We're gonna change this one to late update. Recalculate bounds. I don't think we need to do that. We're gonna cache this one as well, but we're gonna do private void awake and private mesh. I want to call it bake mesh. Instantiate it here. New mesh. So we're not going to do that. Actually, I want to mark this one dynamic as well. Yes. Now this must be extremely costly. Mm-hmm. Mm-hmm. But let's go with something like this for now. Soft body handler. We want to attach this one to start here maybe. So we have add soft body runtime node and skin mesh render game object get component. We do it on a game object. So I want to do. Oh, we actually want to add. Soft body generator, where do we have that? Soft body generator. And then add soft body. So what we're going to do here is soft body handler. Get component. If is equal to no, then we want to add it. Something like this, and that should be enough, I reckon. I want to add one more note for future me. If no other way, optimize by disabling an out of custom, etc. Okay, let's see if we get some proper normal recalculations this time around. Yeah. Okay. One sec. Blob, do we have creature animator? Whoa, 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 whoa. We don't have... It has animate entity, attribute handler, animator, soft, just body definition. And creature. We don't have a soft body handler on this one. Where do we have it then? Did I screw up this badly? Add soft body runtime node. Get component. Ooh, yeah. That's what we want to do. So if we can't get one, we add one. I think that is it. It looked pretty damn good. When it fell, this one. Let's see if we have it. First of all, we have a soft body handler here. So now we should get some proper recalculations here. I just want to see, like, every time I see a blob that has some very nice dynamics, I want to check what kind of settings we have here. And we get recalculations as well. You can see, like, it looks so much better. The shading, that is. But I guess the best test would be to add 1 0 here, makes it a little bit heavier. And we can see here that we have recalculated normals because we get this very nice shading. That actually looks extremely good, I would say. And I think we get recalculated refraction as well. If we remove this 0, I think so. Yeah, we do. Like, I can't wait for actually like create some procedural generation, procedural animations for these blobs as well, like jumping, making all of these bones move down and up before jumping. Compress and elongate. And look at this refraction we have going with these recalculated normals. It's actually pretty damn nice. And can we see? Yeah, we have the capsule in here as well. The only thing I don't like with the capsule currently is that it actually goes all the way to the top here. Maybe it's easier to see like this. And probably want the height to be something like that eventually. I know what I want to do about the rotation. It's, I guess if we, right now we have joints that are pretty heavy, like 8 kilograms per joint is, that's a lot, but the blob itself only weighs, yeah, it weighs roughly the same. So we have bones that together weigh 10 times more than the actual blob. I wonder if we change this one to 40 maybe. That's, yeah, we probably, now we still have some rotation here. And we have a lot of rotation. I don't know, angular damping, we probably don't want to go too high on that one. I still want it to rotate, but maybe rotation will be controlled by something else. We'll see. And I mean, in extreme conditions, it still doesn't look too good. The deformation, that is, but I'm wondering if that is shadow artifacts we're seeing. Like, do we want to go even thinner on the capsule collider? I want to see what happens if we have like a radius of 0.6. Yeah, maybe that's even better actually. We're probably gonna get more issues with interlacing colliders, but it's gonna take a while finding the... Oh, this one looks good. Yo, what's up, Klaus? like finding proper values for these joints and stuff like that is probably like, I want variation, but I also want it to look good in like most cases, all of them pretty much. I think this looks good. So what about this one? Yeah, next step will definitely be to add the angular drag. Tell us the stream starts lagging when you push it around, in case you didn't know. Thank you, appreciate it. I had someone tell me the same yesterday. It's extremely weird. My stat looks pretty good. It shouldn't be that heavy calculations. I'm gonna have to look into it off stream. Maybe give my OBS some more priority over the computer resources. That is definitely too bad. We will worry about that after the stream. This one is done. We're gonna wait a bit with this one. I just have to ask real quick. I know that Unity 6, like the recalculations of the UI or updating of the UI takes a lot of resources. I'm talking about all of these values here for some reason. Does the stream still lag if we have it selected like this? Because I think my output values from OBS looks pretty good still. Okay, that is unfortunate. Okay, let's do less laggy stuff for a while now, before we try it again then. And thanks for letting me know. Okay. When we add a rigid body here, I want to be able to add... What values do we want to add? We want to add... Mass we already have. Yo, what's up, Ice? Mass we already have. I'm thinking about linear damping, probably yes. As well as angular damping. Although I'm wondering if... Yeah, I want to randomize these as well. So when it comes to the blobs in game, they are going to behave like widely different depending on properties. Like how firm or loose they are. And all of these properties are going to be... Yo, what's up, Star Platinum? Yeah, I know. Find it extremely... It's probably that, like, OBS priority is low. So when Unity asks for more resources, it takes it from OBS. And when that happens, OBS can't output as many frames, you know. That's just a guess. I'm gonna have to look into it off stream. But what I find weird, however, this must be something new, because we have done way more computational heavy stuff on stream before. Like insanely more. So I wonder if it's something new, with the latest OBS version, or something with the latest Unity, or just that my computer is getting extremely old. But I will do my best to get to the bottom of it off stream. More computational heavy things before, such as I would guess that when we did the grass shader, like, this is a very simplified soft body. This is just like, this soft body is just 9 bones with box colliders that skins a mesh. That's all. So 9 springs and 9 bones. If we take a look at our character, for instance, this one is skinned with so many more bones. Yeah, I think I have a image on my Twitter, or X, sorry about that, showing the grass, and I mean, the spring, we even did cloth simulation with, I don't know how much it was, but quite a lot. It might actually be, we'll see. I will get to the bottom of it, I hope. But okay, let's see here. So as for our rigid body for the blobs, so when it comes to linear damping and angular damping, I probably want... So what I think we will have eventually is we will have a variable here that describes the firmness of the blob, and that variable will affect... It will affect these things on the blob. So let's see here, where do we have the blob material? So we have some variable on the material itself, like volume density and light shine-through rate. Both of these variables will be decided by... So if we have a thicker blob, a more firm blob, we will have less light shine-through and volume density will be higher. So you will actually be able to see on a blob if it's going to be extremely wobbly or not at all wobbly, you know? That is the idea, at least. And I'm thinking that when it comes to the rigid body mass, linear damping and angular damping, these are going to be affected by the same one. So we probably want to add them as, not as options, but as inputs here. Let me just test one thing as well. Do the stream lag if we do the spring testing like this? If we do the spring testing like this, do we have lag on the stream as well? Maybe it's too... It's not nearly as much computational stuff that happens. Thank you, Kalos. Yeah, the grass is pretty nice. When we went all out on the realism of the grass, I think it looked extremely nice. We just have to cartoonify it a bit. That's why I haven't shown it for a while. Okay, so this actually lags in the editor as well. Or it's not lag, but... I love how these soft bodies works. But okay. So let's add angular damping and linear damping here. And then we can watch it lag a bit. So add, or is it set rigid body editor node on define ports? We have mass. Actually, we can start with adding here. Let's call it linear damping and We're gonna put it here. Angular damping. And can we get... Okay, good default values. Then we want to send this one in. Unfortunately, I can't give the cartoon grass sneak peek today. But soon enough, soon enough. Linear damping and angular damping. Let's go to add rigid body runtime node. Not that one. Add or set rigid body. Okay, it's actually add rigid body runtime. And then we want to fetch, first of all, our node now takes 2 more inputs. So we're going to put 4 here. Like this. But I think, you know what? Let's make it a little bit nicer. So if it's bigger than 0, then we check if it's a float. And then we want to get these values as well. Float. Linear damping, angular damping. Star Platinum, I'm rooting for the next video. It's so long. Yeah, and I know. Fuck, my schedule have not allowed me for enough time for the new videos. Hopefully this summer I will be able to produce some nice videos. Like I'm dying to make them as well. I have so many nice ideas. Especially for like showing dynamic shader editing and seeing the result in the video side by side. It's gonna look so sick. And Star Platinum, not gonna lie, you've been doing so many random things. They might look random each to their own, but together they're gonna build a nice dynamic world, I hope. If my computer can handle it. But I think, so like, the video I'm working on right now is just gonna be a quick... I want to get into like the video editing again, so it's just gonna be a quick rundown of a simple animator controller. Getting like the run and walk and idle animation running. But then we're probably gonna do... Yeah, then we're gonna do the cloth skinning. Or the apparel skinning to the character. Then we have some different options. Maybe grass. We'll see. Rigid body drag, rigid body angular drag. Please use. Okay, we better listen. Linear damping. Fuck. Angular damping. No, thank you. Something like this. Let's see if this works now. So from our procedural graph to our actual creature. You only have 2 creatures at the moment, right? Will there be more? Yeah, we only have 2 creatures right now. We have 1 static stone creature, which still needs a little bit some visual improvements. And then we have the blobs, which are shaping up to be pretty amazing actually. Apart from the fact that it crashes my OBS then, but So linear damping, I don't know, linear damping we're probably gonna go quite small, I think. 0.5, 0.4, 0.6. For now. Actually, let me add one quick to-do here. Make all the different blob visual and functional properties depend on one or maybe two variables. It's gonna be so cool when we get them. So as for creating new creatures, I definitely want, like, I want many creatures in this game. I mean, most of the heavy lifting we have done here, so it shouldn't be too hard to add some small variations of the current creatures, but I want to be more creative than that. But the idea is, unfortunately, to like keep it at 2 for this year. I don't have the time to add more creatures now. We're gonna focus more on like creature behavior next. So we're soon done with the blobs, and then we're gonna jump over to like how the blobs behave in the world. So I want to be able to feed them and pet them, and I want them to be happy or sad depending on what we do. Maybe even want to be able to kill them and stuff like that. So we actually get some creature related gameplay going. Because right now we only have like kicking them around, and that's, I mean, it's fun. Angular damping 10 on my character. Let's go between 8 and 12 for the angular damping. And put it there, and let's see if it works. I wonder if it's a CPU problem actually. It might very well be. So here we have the blob, we have the rigid body here, and now we have linear damping of 0.45 and angular damping of 10. So that's good. Which doesn't affect this. Ooh, these joints have a very weak spring and a high damper value, so we get something like this. It's very jelly-like, I would say. Extremely jelly-like. So when it comes to a blob like this, if we take a look at how it visually looks, I would probably... So it's pretty clear here. For a blob with this soft body dynamic, I would probably want to go with a higher volume density. Make it a little bit more like this. We probably want to have some more blurring. So we're talking 2, maybe even 3. And finally, way less opacity. So maybe something like this. This, for the blob visuals, lines up a bit better with this. Right? I would say. But okay, so unfortunately we're gonna get some stream lag now when I try this out. That is rough. I wonder... Yeah, and then we have the interlacing problem. That's on the to-do. I mean, it's slow, but the bones are still... I guess... For this visual, I would guess it's should be a little bit more firm, right? Yo, what's up, Wesley? Yeah, super jelly as well. Jessley, can I ask you, does the stream lag on Twitch as well when I collide with the blob? A little. Yeah, that's unfortunate. Yeah, I'm gonna see what I can do about that sometimes. Sometimes it stops for a sec. Yeah, that's extremely bad. But okay. So, apart from the lag, it's not even when you touch the blob. Just render part, it's your voice. Yeah, I'm gonna have to look into this. So that's one more task I'm gonna have to check out off stream. But okay, the linear damping and angular damping, beautiful. Yeah, it's a single PC setup. And Unity eats from the OBS resources, but I should, like, this is not that heavy. But I'm soon happy with how the blobs look, so I will look into it off stream, see if I can fix it. But let's see. One sec, let me see. Yeah, I'm pretty sure it's like Unity hogging the resources, so OBS doesn't get enough to properly produce the frames that needs to be sent. But okay, let's see. Add option for angular drag to blob RB, done. Add graph option for number of skinning bones. So this one, Wesley, maybe you can give OBS higher priority. Yeah, definitely. That's going to be my first thing I do as soon as I end this stream. Add graph options for number of skinning bones. So this one is a little bit, I'm not entirely, so this is an option we're gonna have in the options section here. No, I appreciate it, Wesley, I appreciate it. So these options we have here, these are universal, so every blob will have the same options here. They are more, so these are unrelated to how each individual blob actually behaves, and more how all blobs behave, right? Like use gravity settings and stuff like that. And when it comes to skinning, so when we generate a blob, we add X bones to it, and then we go through each vertex of the mesh and skin each vertex to different bones. Currently we are running a add soft body runtime node. Currently we're running a 4 bones per vertex setup. And I'm thinking that this is probably gonna be the upper bounds for it. Because the performance is gonna degrade quickly when we increase this one. So we're gonna have to find a value on the where do we have it? Here. In method parameter A, this one and 4 bones is gonna have to work closely together to actually produce something that looks okay. 4 bones per vertex is, I think that was like the old limit in Unity for skinning things, like back in 2011. This time around, if you use bone weight 1, we have talked about this quite a lot on the stream, right? But the current limit is actually limited by the number of bits representing the integer that decides this. So I think we have 8, which we have 255 as the upper limit. I definitely don't want to go that high. I want to stay at 4. But so this might actually be, whatever we add here is eventually, like far into the future, it might be related to the graphical settings. So if you have a very powerful computer, we might switch it to 8, while the default is going to be 4, you know? But I want to add this option. I don't want it to be hard-coded like this. So we are gonna add, and I wonder if it's time to add a yeah, I think it's time to introduce a so I've talked about this previously. So this is Unity Graph Toolkit. We developed our own procedural creature generation graph in here, and we have a little bit of a problem with nodes, the input to nodes. So I want my nodes to be able to support inputs like this, i.e. we add our inputs here and it should convert to a proper a runnable graph. Right now, if we just do this, I think we're going to get an error, because in the runtime node or at rigid body, we are going to try to fetch that input like this. So we try and get input from another node, but with this setup, we don't have another node here. And I want to fix that. And I don't want to have something like this. So I don't want to have, in the editor, I don't want to have a float constant like this. We shouldn't need to do this. Instead, we should just need to do this. So in our, what is it, export, creature generation editor graph exporter, in our exporter here, if we notice that we don't have a node connected to the input, then we should create, yeah, we're going to create a connection. Not a node connection, but a value connection, which I already have. But I don't think we use it. Can I see if this one is being used somewhere? No, we're not using it at this moment, but we're going to use it now, okay? Wesley, well, I mean, if you have a slightly more complex shape, this is just a cube. If find nothing, use default value instead. Yeah, that's what I think. We're gonna represent the default value with something like this. So we're still gonna create a node, but it's gonna be yeah, it's going to be represented by a value connection. Let's see if we can make this one work. I feel like this is a different lag. What kind of lag are we talking about now? I'm running threaded, so it shouldn't be an internet problem, I hope. Beautiful, I already had this one. So we just need to find if output index is... I wonder if we have it like this. Get output port index in and generation to runtime nodes contains key previous editor node. Else failed setting up input. Yeah, let's see if we have this error. So now when we have it like this and let's clear all of this and let's save it. And we have... No, we don't. Failed. Okay. I was pretty certain that this one would fail. And you know what? Yeah, okay. Output port get node. I think we fail here actually. Failed real. Like this is one of these things or those things I've postponed for way too long. We should have had this working for a while ago. Failed. We don't actually get it here either. Doesn't it count it as a input port count? I want to see. Let's add a proper debug here. So let's do unvisited nodes, editor node. Let's do debug.log editor node dot type. Can we do this to string? Has inputs. Yeah. Okay, so we get this debug, and what do we have? Add rigid body runtime node has 4 inputs. So we actually, this one is an input, and I was setting up input 0, 1, 2, but not the third one, right? So somewhere between here. Okay. Yes. Get connected ports. So I guess, yeah, we don't get, that's pretty weird. So what we could do is we just change this one to a for loop. I wonder if this one is gonna return output port connected ports. Yeah, we don't get a connected port here. Do we have a better way to solve this? I wonder if we get an error if, for instance, if this one was connected and this one wasn't. I wonder if we get an issue then. Let's try it, I guess. Output port. Get connected ports. What more do we have? I would like to have, instead of creating this connected ports here, we do a input port count. We do it here. Oh, that's true. Okay, so we get 0 here. Okay, so for each, so I guess we can do if connected ports dot count is equal to 0, else we do this one, right? Because I think this is a fail-safe for input port. Yeah, let's do this. Because the reason we do this is, for some reason, if we have more than one connected port. But that's weird. Input port. Yeah, let's copy this one. Input port of has no connection. Random runtime node. What? Oh, yeah. But I want to see input port, what is it? 3 of add rigid body runtime node has no connections. Okay, beautiful. So this is how we identify it, and this is where we create a value connection, pretty much. But then we're gonna have to read this value. It shouldn't be too hard. Dynamic UV sphere mesh generator. So we're talking about this one. Yeah, we have longitude segments here. Okay. I guess I would like to create it here as well. So currently how we solve this issue is, so this is a quick fix as well. We do dynamic mesh generator editor node. How we solve it currently here is, so we have pretty much defined this input is a node input 100%, or this node input is a value input 100%. So we solve it like this. Where do we have here? Longitude segment. We just do get input port by name and try and get value. And this is how we get a value. From it. So, but this is a subclass of or a method we inherit from generation editor node. I'm not so sure. I think we get it from maybe node actually. But yeah, it shouldn't be too hard. But I want it to be a little bit nicer, so add input, yes. One thing is, yeah, we have the index, don't we? Yeah, so we pretty much want to create a connection. Connection is equal to new value connection, and then we're gonna have to get the type here. Type, and then we have the value, and then we have the index. Type. In these setups, it's hard-coded the type. How the fuck would we handle that? I guess we could try and add input port. We should have the value here, shouldn't we? Add input port. Let's see. We are working with connected ports. It's an I. No, it's not. It's a input port. I port. I port Unity graph. Cool. API. Yeah. Data type. But we can't use this result here, can we? Do we need to specify it here? Maybe we can do this and let it handle it itself. Value, connection, runtime connection. Yes, I think. So can we just do methods is connected, try get value. Do we need it here? Try get value. And we call input port try get value like this. I want to go object here. But maybe we have to actually. So I wonder if we can do this. Try get value. Like it's this extremely up. Value. And then we do out value. Like this. and then we do value, and index is equal to I, value connection, and then we create a constructor where we do public value connection object value int index. But you know what? We're gonna have to set this somewhere. But then we can probably do object value type. Dot type. I don't know exactly how we're gonna solve this. Because I'm pretty sure we can't. Or can we cast it like this? No. And I'm pretty sure we can't do this. Object, sure. So we have some iPort that returns a value of varying types. And we want to convert it to a value connection of the same type. You know what? I mean, we could add support in, if we jump to the editor nodes themselves, we can probably define the output type there. I don't know if that is something I want to do.
Don't stop.
We have data type. But you know, like when we add the input port, we know what type it is. I'm wondering if we want to add Do we want to add some like setting here? If we add an input of type this one, we store it somewhere. We could also... Okay, I think... Oh, one sec. We do something like this. Ish. Well, the first problem is that we're gonna have to know the type at this point, right? Because we can't get the value any other way than try get value. I guess. So then I'm wondering if we wanna do... There has to exist a better way than adding a method here that handles it. Pretty sure. add rigid body editor node. Add input port float. Here we define the type. iPort data type. Now, I'm wondering if the only option we have is to add oh, you know what? Fucking hell, we're gonna do it like this. We are gonna do it like this, I think. But that's gonna add a lot of code. But what I'm thinking of doing is, so get node. Like, I'm wondering, when we do to runtime node, if we try and get value like this, but if it fails because it's a connected node, I'm wondering if we're gonna set up the value connector here instead, because then we know the type. But this is option, by the way. I'm talking about add rigid body runtime node, so here. So we have the type for a lot of these here. Mass we don't even get, do we? Never mind, I'm not talking about this one either. I'm talking about add rigid body. This one doesn't have it, but dynamic mesh generator here. I'm talking about adding it here. Adding some logic here, because here we know the type. Because we have defined it ourselves higher up in the class. But that means that I'm not so fond of that solution, because that means that we're gonna have to go through every editor node and handle it individually. Has to exist a better way. Because basically what we want to do in the exporter here is we want to get a generic type. We want to get a generic type. Have default value. And you can't do... Can't do it like this, right? I guess we can do type of. Type, I thought. Yo, what's up, Scafer? Make it a generic. Yeah, I think that's the whole problem. Like, we get a generic value from a generic or a class that holds generic values. And we want to convert it into another class that holds generic values, right? I've never been this deep into generic values or generic types, whatever the correct term is. So we have a value connection here that can be value connection float, value connection int, and so on and so on. And we want to create a value connection from a I-port, which can be a I-port float, I-port int, and whatnot. We can get the type. We can get the type out object value. Is this enough? Object I-port dot get, no, not I-port, but input port dot get type. So something like this. Now we send in the correct, we send in a value, but it's of type object now. We send in the type. We can't do it here. So yeah, we're pretty much fucked. At this point, like, the compiler needs to know what it is, I guess. Okay. The correct way to do it is probably to do... I guess we can skip this whole thing. If we do... Let's try it with add rigid body. So instead of getting... It's this one I want to try it with, right? So input port. Guess we can do... So we could do something like this. It's sturdy to do it here. Is it possible in C# to create a convert one class holding a generic type, another class holding same generic type, without actually specifying type? What a weird question. Scaper, I mean, there's a type converter class, but you shouldn't really use it if you don't need to. Also, why don't you need type if you can just pass an object? Like, the thing is, at some point we're gonna have to convert the object to its actual value, right? So value connection is, it represents a connection into a node that only holds a specific value, which can be float, int, whatever. We have an editor representation of this, and then we have a runtime representation of this. And at some point we need to convert the editor representation to a runtime representation. And it's that conversion. Generic helper method, generic converter. What the fuck are we doing here? If type unknown at compile time, that's probably what we want to work with. Get type, source type var, get generic arguments, target type, type of target, make generic type, target instance. Object source get type. If we have interesting. Fuck. Escape, you can also make a conversion operator in your value connection that would convert input port to value connection. That's how Moonsharp works. But like making a conversion operator in the value connection that would convert input port to value connection, that would pretty much just be moving whatever we're gonna do here to the class itself, which is pretty nice actually, which we might do, but like the conversion still needs to be happening somewhere. Honestly, this one, if type unknown at compile time. Yo, what's up, SigTech? Why are you converting? So, iPort is a class in the Unity Graph Toolkit, right? That's what we use to... or we utilize it to define our graphical graph. We need to convert it to a runtime graph. To be able to run it at runtime. What message in chat did I skip? I'm still not sure what you're doing and why. You just need to store the value. No. Okay, let's explain this. One more time. So this is our graph. That is, here we define how a creature is procedurally generated, right? This one utilizes Unity Graph Toolkit. We use some classes created by Unity to be able to get this visual representation of the graph and how everything works and so on. At some point, this needs to be converted to a graph that we can run at runtime. So we have an exporter which pretty much converts every node here, which is a star editor node, into a star runtime node, and then we store them in a scriptable object. So different nodes here are going to have different inputs. Some of them has integer inputs, some have animation curve inputs, some have float inputs. Some of these inputs are going to be connected to other nodes. So at runtime, we just link this runtime node and this runtime node. And when this one needs the input, we just generate it as an output from this node, right? But in some cases, we're not going to have any input nodes. So instead, we want to take whatever value is stated here in the editor node, and we want to pack it into a value container, which is then used in our runtime graph. And instead of like figuring this out in every separate editor node, we want to have we just want to do it at one point. And that's why we take a little bit of a detour and create these value connectors. So store object value. But how would that work later on when we want to fetch that value, when we want to do some calculations with object value? So what you mean is that we could cast it here, pretty much. If I understand you correctly. So we could do... So what you're saying is that we do... that's value is equal to null. We try get the value, and then we send in the value, and here we do it as an object. So we do it like this, and then we just rely on this cast entirely. That might be the cleanest solution yet if it works. Yeah, you're definitely correct. Like, if this works, this might be... I wonder if we have any downsides here. Thank you. This might actually be... Let's try it. Let's see what we have. So... we create this value connection here. And then we do generation runtime nodes, editor node, add input connection I, something like this. I would be extremely happy if this works. What I'm a little bit afraid of is... maybe it should. We'll see. So we're gonna try this with angular damping here. So previously we had this as an input that had to have a node connected. This time around we're just gonna try it with a... Let's try some weird value then, 10. But we're gonna get some errors here currently, I think, without this one. Or are we? No, I don't think so. Let's try it. And we get... Failed. But that shouldn't be this one. Rigid body runtime node. You know what? Or let's see here. Take a look at our visual generation graph. Ooh, I might actually know what. Albedo, do we have? Let's see here. Add rigid body somewhere. Add rigid body runtime node. Inputs for element 3. Okay, we don't have a node here. That's good. It's so hard to know if it's this one that fails or what it is that fails. Fail to generate at rigid body runtime node. That's the first failed we get, right? I think so. Try get output. I'm pretty sure, or my guess here would be, we can try it. Connection, runtime connection. We're gonna add a little bit of a debug message here. Let's see if this is the culprit. Got value. Let's just do a simple from value connection, and then we do failed to get value from value connection. It might be my exporter that fucks it up as well. We're gonna double check that one eventually. Let's save this graph again, clear it, play. Value connection. Failed to get value from value connection. This value so we try to get a float here with t as float, and when we check if this one is this, it's going to return false most likely because this one is an object and not a float. That's my guess at least. So at some point before this we are gonna have to cast it. Scafer, that's why I'm saying that you don't need a generic. I'm just trying to follow here. At some point we're gonna have to get a float. At some point we're gonna have to convert this object to a float, right? So if we don't run with this generic solution, at what point I'm just trying to understand if we don't need a generic, how do we solve it? It's not always going to be a float. For this node, it's always going to be a float, but sometimes it's going to come from another node, and sometimes it's going to come from Scafer, make it store object, and if you need to get an argument as some type, you make a function like get value t and convert it inside to t. Type inside it. So I guess that would be, we check else if this dot value as t type value. But we can't use it here. Yo, what's up, Jash? I'm good. How about you? How about you? Checked out your Steam page yesterday. It looks very nice. Looks like a real fucking game, you know? Paper, make it store object, and if you need to get an argument as some type, you make function like get value and convert it inside. Yo, what's up, Valley? What are you trying to do? We have a class that can have generic types, and we want to convert it to another class that can hold generic types. But we would prefer to not specify what the generic type is. What it all comes down to is that we have a class import that holds maybe a float, but it holds like t, and we want to convert it to a value connection that holds t, you know. And at our disposal, we have import.getType, which returns the type. We also have import.getValue, where we need to specify the type. Out t value, something like that. Okay, if this is t guard looks redundant, where do you get the t? You are putting it yourself, so you know what's inside because you self-specify the t by hand. Yeah. But so what you're saying is So it's like at somewhere we're calling this function, right? Get value. What example should we take? We can take average body runtime. So here we do try get input float. So for this connection, we try and get a float. If we can't get a float, we fail. For this one, we try and get a game object, you know? So like we have... Just assume that when we try and get the input from a connection, it can be any type. But at some point we have to specify it. And here we do it like when we try and fetch it. We know, at this point, we know that it's a float in here. But before this point, we don't know what's inside. Valley, can't you do import.getValue, import.getType? No, we need to do like try get value is it returns true or false if it succeeds or not, and you put like we have an out parameter here where we put the value. We can definitely make it into, I don't know, Scafer, I think you're overcomplicating. Try. I don't think I am. But I appreciate if you can point out that I am, because we want to keep things simple, right? Try get value is just a fail-safe previously. So try get value, and not. Are we talking about this try get value, or are we talking about try get input here? So try get input, it just takes an input index and tries to get that one. So then we call get value, you know? Then we decide the value here. So you mean that this one is redundant? I don't know. So get value, yeah, here we double check, like the value we're trying to fetch and put into this variable, is it actually of this type? That this is where we do it. So currently this is where some generic type actually quote unquote becomes the type we want, you know? And what I'm getting at is like at some point we need to do this, right? Fuck, time flies by. Valley, this value is T typed value, could just be T equals K. No, it could not. Because then we might actually be working with like reference typed values, and I think no, maybe it could actually, but that would just be another way of writing this, I guess. Scafer, and you're using the generic in the wrong way around. I'm saying you can store private object value without K, and then in get value check it. Currently you're setting your K to object and then trying to get float outside. I don't know about that. And what do you mean? Like, okay, so let's say that we store private object value. Okay, so at no point... Like, I don't have the time for this, unfortunately. I'm gonna have to run soon. But what you're saying is that we skip k here. We just have object here always. And then we have a get value where we send in t. And we cast it, right? So currently it's float is object, which is false. But the other way around is object is float. So what you're saying basically is that we should have value connection, skip the k, keep it like object. We change this one to object. Let's call this one O. O. So now we have object value is equal to value, and then we have get value t type, and then this value is t type. Could we do this? Is this what you mean? Then we're gonna have can output t value is. So something like this. Am I understanding you? And then we have the exporter here. So we do connection is value connection O. We skip this and we just do it like this. So now we have value connection O. We get the object, we just keep it as object, and then when we try and get the value, that's where we define. So we try and get float, and here we cast it. I would love if this worked. I think. Fail to get value from value connection. This is the old one though, so this might actually be related to be able to test this one. I would need to check. We have some other nodes where this one might fail. If connected ports, I'm gonna check. I'm gonna add an ugly check here, and editor node is, what is it? Type of now? Type of add rigid body editor node. Or we don't need type of actually. Okay, so now we only do this for the rigid body. I need to rush it because I need to run. I've got some other things I need to do today. So I might or might not leave on a cliffhanger. Yeah, failed to get value from. So I think if this one is an object, we have no way of knowing what type the object is, I think. Like, I would love to continue this, but it's gonna have to wait. Maybe I will be able to stream on Friday, I just don't know yet. Otherwise, next Monday. By then, hopefully I've fixed the lagging on the stream. And value.getType equals t. Okay, let's do one last test before I have to run. So value if value.getType equals t. Guess we're gonna have to have type of t. Oh, you know what? Yeah. Okay, I get it. You mean that we check it here? We're gonna have to leave it on a cliffhanger because I need to run. Maybe I can post in my Discord. Maybe I have the time later today to try what you're saying, and I can post it to my Discord. The result. Appreciate the help. Appreciate you all. Thank you so much for watching. Peace.